When we are fault finding a problem, it's often a case that we miss something very basic and very simple right at the start of the fault finding. That comes back to bite us. And this is just such a case in question. I'm going to take you through a problem that occurred on my railway and the process I used to fault find it. And to make it a bit more fun, there are plenty of clues for you to work out exactly what caused the problem. So let's see if any of you can work out what the fault was before I get to the end and give you the answer. All the clues are there. The problem is that after re-railing a derailed train, the DCC controller went short circuit. The locomotive contains a DCC sound decoder, and all the coaches contain the DCC version of the PMP-19 coach lighting kit. First of all, I removed the entire train and reset the controller. I then visually examined the locomotive and each carriage before replacing them on the track one at a time. I found that it was the end coach that tripped the controller when replaced on the track. I then removed the end coach for electrical test on the bench. And here we are on the bench. The axles use pickup springs and one wheel must be live to the track. What I'm doing here is checking for shorts across all four axles. There are two bogies, of course, to the coach, and the bogies are connected by common wiring. However, the axles were found to be okay. I then removed the body shell of the coach and disconnected the stay alive circuit and the coach lighting circuit in turn. Once again, the short was still present. I then removed all of the components, leaving only the chassis of the coach, the axle springs, and the connecting wiring. But the short still existed. At that point, it was time to go and have a cuppa and a think. After about a 20-minute break, I replaced the chassis on the test track, and the short had disappeared for no obvious reason. I decided to reassemble the coach and I placed it back on the test track, and the short reappeared. Clearly, there was something very basic, very simple that I'd overlooked, and it was time to go back to the basics. This is the test that I did not do initially. It's a continuity test between the two bogies. I did not do that test because I assumed that because the coach had been working perfectly okay before the problem, that there was no way that a fault could have occurred that could cause a short across the bogies. Wrong. This is where the short circuit was. The bogies had become a short circuit through the common wiring. But the question is, how could that possibly be? Let's look in more detail at the end bogie. The clues had been there all along. And the first one was that it was the end coach that was the problem. The end bogey on the end coach does not have a coupling. Because it didn't have a coupling, it enabled the bogey to turn round through 180 degrees when it left the track, therefore placing the wheels on the opposite rail and causing the short circuit. The fact that there was no coupling there meant that I missed the visual clue of the bogey being turned round through 180. This meant that when I lifted the bogey off the test track, sometimes it turned through 180 degrees, sometimes it didn't. The moral is assume absolutely nothing and check for everything.